Start guys. As I told you, we'll do hydrocarbons. Today's class will be a mixture of whatever you guys know and the most important concepts for this year as well as second year. Okay. We've spoken about the importance in the previous time itself. Let's not waste time there. Let's start off with the chapter hydrocarbons. Okay. And that's how it works. Hydrocarbons, introduction not at all required. Whatever was there in 10th standard, copy paste that part. Everything is repeated here. Everything, including a lot of reactions. I am not trying to tell only those are enough, but each and everything, whatever you guys learned there, including nomenclature, okay, is being repeated in this specific chapter. I'll brief as to what and all things are there, which you guys already know. There's something called as saturated hydrocarbons and also something called as unsaturated hydrocarbons. You should know about this. Saturated means already satisfied, same 3 letters. Unsaturated, not yet satisfied. Okay. The reason I'm using the word yet is because there are a lot of concepts when it comes to your first year chemistry. I realize that in 10th also you have learned something called as methods of preparation, but the problem here is in your 10th standard, it is not heavily focused only on methods of preparation. A lot of other things are there, and moreover, even in methods of preparation, we choose few of them. Don't get confused. I'm talking about a lab preparation of whatever in 10th standard. Here, methods of preparation has to be given a lot of importance. In fact, once you guys come to your second year, no, there's a concept in organic chemistry. It is called as aldehydes, ketones, and carboxylic acids. Methods of preparation are around 50-55 are there. Just imagine aldehydes or ketones can be prepared in 55 different ways. This is what we know in our syllabus. Just imagine how many actual ways it can be got. So it is a crazy thing. So saturated always means one category called as alkanes. Okay. This are 2. Double bond as well as a triple bond. You guys know the names. Alkenes as well as alkynes. Fine. Don't add anything. I'll tell you what I'm going to write. In fact, I sent you the notes. Okay. Notes actually more than enough for this. This is the explanation here. Okay. Now focus. A lot of concepts will be asked in a direct way. Convert this unsaturated whatever hydrocarbon into saturated. Now the unsaturated can be anything. It can either be a double bond or a triple bond depending on the question. You have to convert each and everything in terms of alkanes. Now always understand, whenever we are trying to convert an unsaturated haloalkane to a saturated one, we always use hydrogen, some sort of hydrogen at least. Fine. So how many number depends. For this, only 2 might be required. For this, 4 might be required. That keeps on changing. I'm talking about the balancing number might change, but the concept remains the same. So we are supposed to use hydrogen in order to get the answer. That's the basic thing. We understood. That's one of the ways to break the concept also, to convert unsaturated to saturated. Now, talking about the next part. What and all was not there in a 10th standard, like in a complete in a proper way. We talk about that also here. All these things they come under a concept called as aliphatic. Okay, not important, but still they keep asking bullshit all these questions. One more concept is there. It's called as cyclic. Remember when we did the other chapter in organic chemistry, we learned something called as resonance structures. Resonance structure is what? Benzene. Now let's talk about this benzene part here. Just an intro. If you see here, benzene has a cycle, end to end. Okay. It starts here, comes back. Right? Now, the same benzene, let's imagine, without the double bonds. So, without the double bonds, as far as we know, 1, 2, 3, 4, 5, 6. 6 in number. Okay. 6 carbons meaning hex. Since it is cyclic in nature, we call it as hexane. Why ane? All single bonds. And it's called as cyclohexane. Got the concept as to how it works. But this will be called as benzene. Benzene. Ene because double bonds are there. Benz because it's a common name used. Fine. But it's also because it's cyclic in nature. Remember all these things. Fine. Cyclic ones very important. In this concept, we'll be learning about both of them. Now focus. Benzene. All these things can also be called as aromatic hydrocarbons. Aromatic, aroma. They have some sort of smell to it. I'll give another example. In your cupboards, to prevent all these cockroaches and all those things, we tend to use these naphthalene. Naphthalene structure is somewhat like this one. Okay, it's somewhat like this. So if you see, it's always cyclic in nature. That's why. And if you see this naphthalene, okay, they have one sort of smell. You like it, you don't like it, is another question. But they have some sort of smell. That smell is, because of the smell, these compounds get a name called as aromatic hydrocarbons. So if they ask what kind of question can be asked, example of aromatic hydrocarbons, I would give you guys two. One is benzene, naphthalene. They won't ask you guys to draw the structure. It's fine. But name is important. Aroma, important, okay? Basic stuff, but still asked. Next. Regular stuff. Alkanes. What does alkanes mean? Alkanes meaning wherever there is a single bond. Okay, a single bond is called as alkanes. Wherever the single bond, all these things are called as alkanes. Isomerism, structure, all these things you guys know. Now, what are we supposed to learn in terms of 11th standard? I'll tell you. Cool. Fine. So basically, it's actually there. 1 second, please. It's cancelled. Don't worry. Okay, this concept is there. Fine. So let's say I talk about one carbon. I'll name it as C1. Fine. I'm only focusing on C1 carbon. Okay. If I ask you, after some point of time, I'll attach 2 more carbons because it's my wish. Okay. Right now, okay, 1 second. Right now, C star I name. Now let's start with numbers. C star is attached to 1 carbon. If any main carbon can keep on differing. Always understand this. In this case, we are focusing only on the star part of it, called as C star. If the C star carbon is attached to a regular carbon, this will be called as primary carbon. Okay, primary carbon. Which one? This one. Why primary? Primary meaning 1. It is attached to 1 extra carbon, therefore primary. But let's say C star got attached to 2 carbons. 1 here, 1 here. It will be, then this will be called as secondary. 2 degree or secondary. Next. Let's say C star is attached to 1 more carbon. 3. Tertiary. Let's say C star is attached to 4. Quaternary. What? Okay. Remember this. So if C star is attached to 1 carbon, why am I naming it a C star? Because in this question, that is my main focus. Okay. If the C star is focusing on, is attached to 2 more carbons, secondary. If C star is attached to 3, tertiary. If C star is attached to 4, quaternary. That's all things. Okay. Now, what else is there to learn? This is very important. Don't write all those things are not required. From now, start writing. Methods of preparation. Methods of preparation. This is exactly what I was going to tell you in yesterday's class. You will realize as to how a lot of similar steps will get repeated throughout this year and throughout next year also. We almost use almost similar steps. Absolutely 0 changes. Fine. Methods of preparation of what? Of alkenes. Sorry, of alkanes. My bad, guys. Single one. Alkanes. Always try to understand, when you're trying to prepare something, we always expect that to be on the right-hand side. Okay? On the product side, not on the reactant side. What should be the reactant that keeps on changing from concept to concept? Initially, once you had methods of preparation, first study, from unsaturated hydrocarbons. From unsaturated hydrocarbons, HCl writing. Now focus. I'll give some time to write. Just focus here. Unsaturated, there are 2 in number. What are they? One is secondary, one is double bond, one is triple bond. Okay, let's talk about both the equations. Now, I'll start with double bond. Double bond are also called as alkenes. Okay, so on the left hand side, also called as the reactant side, start off with an alkene. Always try to give your example with the minimum number of carbons. Minimum. It is good for you, it is good for the nature also. The more complicated your example looks like, the less the teacher might correct it. Now focus. Alkenes meaning minimum it requires 2 carbons. So I'll write 2 carbons. Alkenes mean double bond. I'll put a double bond in between. Now, it is not yet done. Let's go to 10th standard. Again, if you forgot it in 10th standard, I only taught you this. Let's give us a trick again. Wherever hydrogen goes, 1 bond follows. wherever oxygen goes, 2 bonds follow. Wherever nitrogen goes, 3 bonds follow. Wherever carbon goes, 4 bonds follow. This is the trick which I only have been repeating from the last how many years? Fine. Let's apply this trick right now. In this question, I'm talking only about carbons, but the chapter says hydrocarbons. In other language, carbon's best friend in this chapter is always hydrogen. Only in this chapter, I would say yes, but majority of the times, if carbon has no choice, it will always go towards hydrogen. I would actually argue, okay, I feel carbon's best friend is carbon itself. See, if carbon's best friend was hydrogen, why is it not trying to form 2 bonds with hydrogen? No, you might tell, sir, hydrogen capacity is only 1. No, still a friend. No, getting it? How can I give up on a friend? So that's why I won't be able to think like this. So I feel carbon's best friend is always carbon. Apart from carbon itself, it is always hydrogen. Now think here, carbon's best friend is carbon. It is trying to form a bond. But the problem is carbon to connect, they require 4 bonds. Okay. Both of them have to get satisfied. Okay, we try to do it. Now it asks for some external help. Now focus. This carbon on your left hand side has 2 bonds already. Needs how many more bonds to get satisfied? Wherever carbon goes, 4 bonds. Out of 4, 2 got used up. How many more? 2. Getting it? Now don't ask her why you're drawing the bond below. You draw wherever you want. Same concept here. 1 here, 2 here. Who is carbon's second best friend? Hydrogen. Will come and sit here. Okay, now look at this thing for a second. You are trying to get alkane. Alkane meaning double bond, which means focus only on the main problem. Okay, what people tend to do is they try to focus on n number of things, not trying to talk about the most important part. In this case, my job is to break the bond between both the carbons. That's it. I'm trying to make this 2 as 1. The problem is, let's imagine I was able to break 1 bond. How? I'm trying to give it some energy. I'm trying to bitch about it. All those things completely fine. So let's say to both of them. Once the bond breaks, then what happens? The rule does not get satisfied. Why? Once the bond breaks, only 1 bond is between both the carbons. Then think for a second. Think from this carbon perspective. Wherever carbon goes, 4 bonds are required. 1, 2, 3 are there. It requires how many more? It requires 1. Cool. Here, the same thing. This also requires 1. This also requires 1. Now again, think for a second. Carbon broke up with carbon. Who is its second best friend? Hydrogen. So once the bond breaks, carbon will go and ask help from hydrogen. Okay. Now, how many hydrogens does this carbon require? 1 more. How many does this carbon require? 1 more. So totally how many? 2 more. So instead of writing 2H, H does not exist in nature. We write H2. Now, common sense, the bond breaks. Out of these 2H, 1 will go onto the left side, 1 will go onto the right side. Now, for this to happen, we need some catalyst. Nickel. Okay, we need nickel as a catalyst. Now, what's going to happen? The bond breaks. I mean, you don't show the breaking of the bond. I'm trying to explain it to you. The bond breaks. Out of 2H, 1 will come and satisfy this carbon. Then it looks like C, 1, 2, 3. 1 out of 2 bonds, only 1 broke. Why? Because I want alkanes. Alkanes meaning single bond. 1 bond has to be there. Don't break both the bonds. And moreover, it is difficult to break both the bonds. I don't know best friends. How much ever you try to pitch about them, there will be one connected. That's what I'm supposed to remember it. Okay. 1 bond you can break. Doesn't mean you completely ruin the relationship there. Possible. So 1 bond was already there. 1 carbon is here. Okay. 1 more was available. Carbon sits on this carbon. 1, 1, 1. Now check. Everything is single bonded. Called as alkanes. That's no problem. 1 second. Sorry. 1 second. I'll finish on 1 more. Alkenes and alkenes done. From alkynes we'll try. Alkyne.
So,
Alkynes. What happened?
so how many reactions are there totally?
I don't know. Why? What happened?
So you told some 5-6 frameworks yesterday.
5-6. That is no. That is, don't get confused. That is mechanism. Mechanism of 5-6. Reactions are many.
Okay.
Got it?
So
I'll tell you what.
almost everything is like in the one.
Huh?
So everything is similar to 10th grade.
I mean, this one is similar only. No.
It is similar. That's why I'm asking.
I mean, I told you yesterday, no, the first half will do whatever was done, second half will do what was not done.
Okay. What
Got
is
it?
more important, like the second half of the
Both are important. Both are important.
How many marks will the previous equation be asked for if they ask?
1 mark or 2 marks. Chemistry, except for the mechanism, no, everything is 1, 2, 3 only. Only the mechanism will come from. In fact, the mechanism also can come for 3 itself. Correct. It can come for 3 only. 1, 2, and 3 only is chemistry. 3 will all be mechanism questions. 2 and 1 will be like these kind of questions. So even your 5 marker in chemistry is broken down into 1, 2, 2 or 2, 3 or no, I only these two. Either 1, 2, 2 or 2, 3. This is what is being broken down. What's the logic?
Yeah.
So basically, we start with alkynes, guys. Alkynes is triple bond. So C, 1, 2, 3. C, second best friend is whom? H. Think for a second. Wherever this carbon goes, how many more bonds? One more. H. Now think. Here I am supposed to break 2 bonds. Continuous is possible? I don't think so. We'll have to break it step by step. So what's going to happen here is when I try to break both the bonds, initially the plus. I realize if I write H2, 1 here, 1 here, not enough because it totally become 4. It has to become 6 hydrogens. So it requires 2 H2. Common sense. For 1 bond to break, we need 1 H2. For 2 bonds to break, we need 2 H2s. Simple. What's the catalyst? Same catalyst. Nickel or heat. So what happens here? Breaks completely broken. Try writing it without looking at the screen itself. I mean, I'll keep it here, but you start off with this thing. You write alkenes, write a double bond, and start off. Good. Do it. Write both. Once you're done with this, let's go to the second method. From alkyl halide. First of all, what does alkyl halide mean? The next step, focus on, right? Remember in last year, we learned alkenes. Alkenes was CH4. Fine. We used to represent alkyl using R. What does this mean? I'll tell you. From this alkane, take off 1 hydrogen. What is remaining? CH3 remains. This is called as alkyl. Okay. Now, halide, everybody knows. Halogens. Okay. Fluorine, bromine, iodine, all these things are halides. If I combine both of them together, it will look like this. Halogen, we usually represent using X. Alkyl, R. So it is called as RX. Okay. R is alkyl, X is halide, alkyl, halide. Now focus. How do we start off? First, I'll give you a general reaction. Learn how to write general reactions, very, very, very important. First, I'll write RX. To this, I'll add hydrogens. I'll tell you why. To be more precise, I add something called as nascent hydrogen. Okay. Now, what's going to happen here is the bond between R and X will break. Once the bond breaks, R gets separated, X gets separated. Now focus. Whenever X comes out, it comes out with a negative sign. Why? Think about the velocity chart. Cl 1 minus, Br 1 minus, I whatever minus. Which means if Rx breaks down, the X is getting minus, R is gonna get positive. I'll stop here. Instead of giving a general example, I'll go to a specific example. Then I'll come back to this. For example, let's say alkyl. I'll take the easiest example. I take CH3. CH3 is the easiest example. Attach this with chlorine. Cool. I'll break the bond. Fine. Once the bond breaks, guys, all these things you are not showing in your exam. I'm trying to explain you so that you get used to it. The bond between them breaks. Okay, Cl becomes more negative, the whole CH3 becomes more positive. But be careful, you're gonna place the positive sign on top of C. Fine. Now what's gonna happen? Do this, understand a small concept, okay? Chlorine's best friend, okay, chlorine is negative. It wants to get attracted to somebody who's positive. In the whole periodic table, we realize that hydrogen is almost the most positive element. Okay, is actually the most positive, but let's not claim anything. Let's say almost the most, almost very good positive element. Fine. So I'll take hydrogen. The only rule here is I'm gonna take nascent hydrogen. Fine. But there's a problem. If I take one in number, this hydrogen will satisfy chlorine and form what? HCl. Okay. But who's gonna satisfy the other part? CH3 is left. So I take two in number. Now obviously ask my doubt. Sir, hydrogen is positive in nature. H plus will attract Cl minus to form HCl. What about that? Now we'll focus. It is not about the signs here. When hydrogen has two properties according to your second PUC and first PUC. When hydrogen accepts an electron, it becomes more negative, H minus. When hydrogen gives an electron, it becomes more positive, H plus. Two kinds are there. If you observe this properly, in this case, it will act like a halogen. Halogen. In this case, it will act like a positive part, alkane only basically, but not required. It's called as S block elements. You won't know it. So I'm not able to talk about that. Fine. Alkali metal. Remember in this case. Fine. It acts like an alkali metal. This is the regular case. It can also become H minus. So the reason I took nascent hydrogen is because I wanted both the properties. Why? Out of one, I take one of the properties, combine with Cl minus and form HCl. Now one more is there. That H goes and combines with CH3, becomes CH4. So this happened in terms this happened in presence of ethanol, alcohol basically. Ethanol. Okay. Now focus ethanol. Now what happened? CH3Cl, the bond broke. Out of two hydrogens, I used one hydrogen to satisfy the chlorine, HCl form. One more hydrogen, CH3, CH4 form. I apply the same logic here. Now, always remember, when you're trying to write the general equation, if balancing is required, you should show the balancing. What does balancing mean? Here 2 was required. No, you should write the 2 if it is required. Let's think for a second. The bond broke there. Fine. X will have with H. Okay, forms HX. Completely fine. Plus, it requires one more hydrogen to satisfy the R there. Cool. So I put the 2 there. That hydrogen will go sit next to R, become RH. It's called as alkane. HX or HCl or whatever. Okay? Important. This, if you want to write in your books, please write. Exam, don't write. Okay. Sort of. Minutes. More than trying to learn the reaction, try to learn the method. Was to what am I breaking it into? How is the breaking up happening? What is the distribution? All those concepts. Fast. I'll give you 30 seconds. Write both.
So, so why you didn't send work energy notes, sir?
I forgot. I'll send it. Next. Words reaction. Words. Okay. I'll give you a small statement. Write this below this concept called as Word's reaction. First statement, write on. Higher alkanes are formed. Higher alkanes are formed. Okay, that's well enough. Please focus here. Mug it up. Word's reaction. When you come across the word Word's reaction, always sodium is involved. Always a metal is involved. Metal, sodium metal in this case. So I'm gonna start off with the alkyl halide. I hope you guys don't get confused right now. Alkyl halide is RX. Instead of taking chlorine, I'll take bromine. Just to prove you guys, anything is fine. Okay? Can you take chlorine? Yeah, you can. But I'll take bromine this time for a change. I'll take CH3Br. Now please wait. I told you wherever I told wherever the words reaction comes in the picture, a metal is used. Usually it is sodium. Now the hint. You put one more plus. It's actually not required. I'm just going to tell you. You'll put one more plus. What you guys will do focus. Instead of whatever you guys wrote first, called as what halide? Alkyl halide. You will write the same thing. But the other way around, you will write. See, technically speaking, this won't make sense. Technically, it doesn't make sense. Okay? But I'm trying to explain the reaction to you guys. Now, is it balanced? Not yet balanced because I still haven't started the right hand side. Before starting the right hand side, I'll tell you how to remember the numbers also. How many times did you guys repeat the alkyl halide? 2 times. Because you repeated it twice, put that number 2 next to the metal. That's the logic. Now what to focus on? Again, go back to the hint. Higher alkane is formed, which means don't touch the metal. Go back to the first part, break it. Go to the second part, break it. Combine similar terms. I can see CH3 is very common or very similar to this CH3. Combine both of them together. Looks like this. CH3, CH. Okay, now there are how many BRs? 2 BRs. Think for a second. Once the bromine breaks, the BR became minus. This also became minus. What is plus in this case? Metal is plus, Na1 plus. Out of 2, 1 comes outside, reacts with this one to form NaBr, just like NaCl. This also will react with the other Na to form NaBr. So totally 2 NaBrs are formed. Even if you are not writing NaBr, usually they give you marks. But observe here properly. What was my input? My input was a carbon which is 1 in number. My output is 2 in number carbons. Now don't ask me, sir, 1 carbon is there also. No. Both of them are separate. Here they are together. Here it is called as methyl. Meth. Here it is eth. Hint says higher alkane. Meth is 1, eth is 2. Salt. Okay? That's the hint. Okay. There is one thing I forgot. Very important. Catalyst. Dry ether. Forgot. Dry ether. Done. Next part. Very important. What's your question? Okay. Good exam. Next. Next heading. From carboxylic acids. I am trying to get the answer as an alkane using carboxylic acids. How do we start off? Very simple. Before talking about carboxylic acid, I want to teach you a small concept. How do we write carboxylic acid? I'll teach you first. CH3. Okay, fine. Your language. R C double bond O single bond O. H is called as carboxylic acid. I have a small doubt here. Between O and H, obviously there will be a bond. Okay, fine. What I'm going to tell you is, instead of writing H, I'll put one bond. If I write some metal, example sodium, you know what this will be called as? It will be called as sodium salt of carboxylic acid. Okay, it will be called as sodium salt of carboxylic acid. That's the whole point. Okay, using this only, I'll be trying to get the answer. Now, how do we start off? We use the sodium salt of carboxylic acid. I hope you guys are able to understand because this is not taught in 10th standard. Okay, it is there, ethanoate, all those things, but here more depth. Instead of writing R, I write CH3. R means alkyl. Best example for alkyl is CH3. CH3, C double bond O, single bond O, H was carboxylic acid. I want sodium salt. Okay, I took sodium salt of carboxylic acid. Now, think for a second. Such a huge compound, I want an alkane. Alkane is, look at the alkyl group here. Alkyl group is CH3. What we expect in our answers is obviously CH4, which means to this, I am supposed to add actually one hydrogen to get the answer. But the problem here is we have such a huge remaining part of the compound, which we can't ignore. So what has to be done? What can be done? Very important. Okay, listen. We told sodium salt of carboxylic acid. Very easy. Sodium salt of carboxylic acid. I use the word acid there. To compensate this, I'll use a base. What was it? To compensate this, I use a base. Regular base, best base is NaOH. Okay. Now I've asked you how will this base break down? You will tell me, sir, Na1 plus as well as OH1 minus. Nah. We'll do a little different. Because look at whatever is our requirement. My requirement is to satisfy CH3. It requires what? 1H. Check for the H here. Do we have this? H is there. Okay. So that CH3 will break down here. Fine. Will move and combine with this H and form what? CH4. My answer is done. Plus, see what and all is remaining. Totally. In this part, whatever is remaining, combine them together and write off. Totally, how many NAs are there? 2 NAs. So what I'm going to do, I'll write Na2. Next, talk about C. How many C's are there? 1. Fine. How many O's are there? O, 1, 2, 3. None. So sodium salt of a carboxylic acid to compensate that base. We are not breaking it in a traditional way. Why? What is our requirement? Our requirement is just that we need one extra hydrogen. We'll break it up here. Use of the hydrogen, combine them, CH4, whatever is remaining, compress them, combine them together, write the answer. Learning the method is important. Not required. Sometimes if they want to add, they can add soda lime, CaO, if they want to add. Okay, so write it off. Anyways, that is not required, but sometimes it's people. Done. Next. Next thing is what you guys know, but what you guys don't know completely. Okay, you guys know it, but you don't know completely. Right, that thing. Right, that thing. Halogenation. You guys know it, but don't. But obviously it's not completely. Right. Same 10 standard stuff. One heading I'll give you. One word I'll give you below halogenation. Right. Chlorination. Now, is chlorination important? Yes. What is more important is the mechanism. So right now, in this slide, I teach you the chlorination part of it, 10 standard stuff. Next slide, I teach you the mechanism of it. Mechanism, 100% 3 mark. Chlorination, nothing to teach. Whatever guys, the 10 standard. We start off with the alkane. What? CH4. Plus, we add some kind of chlorine, Cl2. We get another condition. Diffuse sunlight, that bullshit, basically. How does the thing work? Out of 4 hydrogens, 1 H comes outside, 1 Cl comes outside, combine HCl. Whatever is remaining, C, H3Cl. Correct? Now what happens? First, step 1's product is always step 2's reactant. CH3Cl combined with Cl2. What's going to happen? Out of 3 H, 1 comes outside. 1 here forms HCl. What is remaining? C as it is. After I use 1 H2 goes there. Cl2. Copy this. CH2Cl2. Add chlorine. Reduce 1 hydrogen. Reduce 1 chlorine. Combine them. HCl. C was there as it is. After reducing 1 hydrogen, H. After increasing 1 chlorine, chloroform. Okay. Next, copy the same thing. Plus Cl2. Reduce 1 hydrogen, becomes C. Increase 1 chlorine, Cl4 plus HCl. Carbon tetrachloride. Same 10 standard stuff. This is not important. What is important is, I'll copy the first step again for the next slide. And then mechanism. Mechanism is what I told you yesterday. Multiple step process is the first mechanism focus. Start off your mechanism always by writing the reaction. By default, you should remember that. So the reaction is, should you write all of them? No. First one is enough. Because everything follows the same steps. So first one I copy becomes CH4 plus Cl2 gives me CH3Cl plus HCl. I copy. Okay. Mechanism is heading. First, understand any mechanisms will have multiple steps, minimum 3 steps. The names goes like this. Always there are, steps will have names, okay. It's called as initiation, propagation, and termination. First, we initiate. Then we move it, propagate. Then we end it, terminate. Okay. So you should write the names, very important. Initiation. Okay. I'll tell you a small statement before talking about this. This is your hint. When you're trying to initiate, look at the left-hand side. Okay. Usually the hint goes like this. Whatever is the heading, that is your first step. The heading says what? Chlorination, which means on the left-hand side, is there chlorine present? It is. Okay. So I start off, I initiate with my heading. Chlorination. I will not write CH4. I will write Cl2. Please don't copy. Listen. Cl2, don't use numbers, use bonds. What do I mean? Write Cl hyphen Cl. Bond you wrote. Fine. This breaks up. So obviously you guys know that one bond meaning 2 electrons. Okay, one bond meaning 2 electrons. In this case, once the bond breaks, there will be 2 chlorine with dots, also called as free radicals. Free radicals. Okay, so initially, what did I get the answer as? I got the answer as Cl2 broke down, 1 on each. Totally there were 2 Cl dots, 2 Cl, 2 chlorine free radicals. Okay, very, very, very important. Now I'll read the question to you guys. Fine. So basically, initiation says the reaction begins with the left-hand side, and you end up getting 2 chlorine free radicals. That's exactly what I told you, but in simpler steps. Now, now focus. How should you get the step number 2? I'll do in the next slide because I have to explain also. Propagation. Okay. How should you continue? To continue, again go back to the equations left hand side. Equations left hand side has had two things. Out of both those things, you used one already. What is remaining? CH4 is remaining. I'll use it. But instead of writing CH4 directly, little smart, you will write, you distribute them and write. Why you will obviously ask? Focus. Technically it is CH4. Okay. Now you will come back here. Why? Step number one's answer is step number two's question. Same concept. Step number one's product is step number two's reactant. Out of two, choose one. Out of two, one. What is enough? Plus. Okay. Cl free radical. What's gonna happen? Okay. Let me not explain the breakup part here. I'll explain a hint basically. Focus. Hint goes like this. Bond will for sure break between that and this. CH3 and H. Okay. Imagine on the second part, there are two things. One is the dot, one is chlorine. Hydrogen likes whom? Dot or chlorine? Chlorine. Which means HCl will form. Out of two things, one got used up. Dot is still there. The dot has no choice but to go and sit on the CH3 part. So CH3 you write with the dot, which means this helped me get methyl free radical. Step number one gave me chlorine free radical. Step number two gives me methyl free radical. We think we are done. No, always understand. Step number one will have one answer. Step number two should have two answers. Step number three will have three answers. But the logic start works. Sort of step number two, first answer I got. Now, very simple. Whatever answer you got in step number two, copy it to the same thing, methyl free radical. Okay, methyl free radical you copy paste. Plus, you will go back to the question. Okay, you will go back to the question. In step number two, in step number two, out of both these things, what did I use directly? I used CH4, what haven't I used yet? Cl2. Now, I'm not telling, sir, in step number one only we used, no? Yeah, so what? Fine. So, in step number two, here, I use CH4 directly. What haven't I used still? Cl2. Correct? I'll write that Cl2 here. At this point of time, you guys know how to write Cl2. How? Cl2. 1 second, I'll check if it has a catalyst. No catalyst. Fine. Now what's gonna happen? Again, think of the left hand side right now has two parts. One is dot, one is CH3. The CH3 likes whom? Cl. Okay. Fine. Plus, which means the CH3 part got used up. Dot is still remaining. It has no choice but to go and hit on the other chlorine. Plus Cl dot. We know the answer for this already. Chlorine free radical. Chlorine free radical. I'll explain the whole step again. Step number one, two things. We start off with a question. Question says chlorination. What is the chlorination? Cl2 breaks down two chlorine free radicals. Done. I go to
free radical on chlorine.
In the which step?
So chlorine, sir, the 2Cl, why is there one free radical?
Hey, metal. How many are there?
2.
That's why I wrote 2. Got it?
I got it, but yeah.
You are asking why is 1 plus 1 2? I have no answer for that. It's like instead of writing Cl dot, I combined them and wrote.
It's an electron. Like you can write 2 dots, no? Why do you write 2? On chlorine.
It's a what?
I thought the bond breaks and forms electrons.
It is an electron only. It's just that I called a radical. Getting it?
Okay, sir, but then you could have just drawn 2 dots on the chlorine, no?
Oh, like this?
Yeah.
Useless fellow. Can't be. It can't have 2 dots.
Why?
Why will it have 2 dots, na?
It's a bond which broke down.
Oh, here.
Yeah, that, yeah.
I can write like that. But how will I show the breaking of bond between two electrons here? Can I do this?
No.
Exactly.
Sir, not like this, sir. Like one chlorine only, two electrons.
We have any doubt in this step?
Yeah, that step only.
What told?
So I just asked, sir.
No, what I mean, you understood as true. There are two chlorines which broke down, formed two chlorine free radicals. Understood?
Yeah.
That's all. In step 2, we want two answers, guys. So I'll go back to the question. In the first step, I had directly used Cl2. Okay. Which means I'll ignore that initially. I'll start off with the whatever was unused. CH4. I write it in a different way. Okay. Then whatever was my first answer, out of two, I take one. I copy. Now H. Remember, this is not one thing, there are two parts. One is chlorine, one is dot. Hydrogen likes chlorine, HCl. Dot should not be ignored, goes and sits on CH3, called as methyl free radical. Now what do you do? This step's answer is this step's left hand side. Copy that. Copy that. Now I go back to my question. Sorry, my equation, first step. I use CH4, I still haven't used Cl2, I'll use it. I'll write Cl2 here in the form which I know. Here again there are two parts, dot and CH3. The dot comes and sits on one chlorine, forms Cl dot. CH3 sits with other chlorine, forms CH3Cl. This is my answer. Now focus. Third step, learn it my way. Third step is called as termination, terminating. I told you it's a third step, so it should have three equations. How to form the three equations? It depends on one thing. Till now, observe one equation, step 1 and step 2 properly. How many types of free radicals you got? I got chlorine free radical, I got methyl free radical, nothing else apart from that. So I got two types. Just right here. I got chlorine free radical, I also got methyl free radical. I got two types. But I want three steps here. Very simple to get focus here. Initially, take the Cl dot. Combine it with itself. Okay? Since you did the thing for chlorine, go to CH3. Take the CH3. Combine that with itself. Next, combine both of them with each other. Check 1, 2, 3. Done. So what did you do? You went to the first step, you realized totally how many free radical types do I know? This and this, two types. Combine one with oneself. Done. One more with itself. Done. Cross. Answer. Cl2, CH3, CH3, also called as C2H6, you can write it directly. CH3Cl. That is answer. So step number 1 had one step, initiation. Step number 2 had two steps, done. Propagation. Step number 3, three steps, done. Got it? Okay. If there's any doubt, ask me. Practice this like 2 times after the class today itself. 100% question. And a new group will be created. I think new group or broadcast something will be created by this Saturday. People whose fee is being cleared, you guys will be getting the broadcast message of the link. Okay. Okay, I will tell this. I told you. Start off. And any doubt in the slides, let me know right now. Don't once I change the slide, then don't ask sir about the previous slide. I have a doubt there. If there's any doubt in this slide, ask me right now. Obviously, when the word mechanism comes into picture, you start off with the equation. Wait one second. Right, step 2, please. I forgot to write. Propagation. Huh? Termination. Hmm. What the fuck is that? Come in. What the fuck is that? Psycho is equal to what? What scam is going on? Okay, guys, see you then. Are you for a lot of things?
What?
Sending myself message and all.
That WhatsApp also is there.
But the other phone doesn't have WhatsApp, only Telegram it has.
Yeah, so you're anyways finding a replacement for Telegram now, no?
What? Oh, me?
Yeah,
The recording has stopped.
I should.
yeah, tell me also, no? After you find.
Okay, guys, see you.